A very good day to all of you. I welcome you once again for the topic Management of Water Resources and Related Infrastructure Part 2. Myself, Professor Juned.N.Bhojawala, working as Assistant Professor in Government Engineering College, Dahod. This content has been structured which is in aligned with GTU Semester 7 subject Infrastructure for Smart Cities. GTU is Gujarat Technological University. Before starting of the session, I would like to thank our principal sir, Dr. KB Jodal sir, and my head of department, Dr. Paresha Baria madam, and all my colleagues and friends who have motivated me for this lecture. So the topics which I am going to cover in this presentation are storage of water, conveyance of water, sustainable water and sanitation, and sewerage system. All these topics are in context with smart cities. So let's start. Storage of water. So the basic storage, as we all know, is basic rooftop water storage setup, where there is a bore or pipeline with the water is supplied through municipalities or through personal bores. Water is collected from rooftop terrace and it is stored in the underground water tank. Usually the size of the tank is 1.5 feet to 1.5 feet to 2 feet. The tank capacity is as per our requirement and as per the space availability. Purpose of water storage, as we all know that water stored is potable water which is useful for drinking. Non-potable water is used for agriculture, for cleaning, for industrial supplies and various other seasons. Apart from this, India is a country which receives rainfall for mainly 4 to 5 months, but we require water throughout the year. So for dry seasons, it is very much crucial that we should store water and then we should use it judiciously. So natural and artificial water storage methods are groundwater aquifers. Now what is an aquifer? Aquifer is a geological formation which stores water. It stores water as well as supplies water. There are many types of aquifers, but basically aquifer is a geological formation. Another thing is soil moisture. Means if soil is moist, then this moisture is utilized by plants or in agriculture, and then plants can be grown or agriculture can be done. There are natural wetlands, whereas artificial ponds, tanks and reservoirs are various forms where water can be stored. So these are artificial ponds, tanks and reservoirs where water is stored. Apart from this, water is stored in water towers or overhead tanks. We usually called overhead tanks as ESR. ESR is elevated storage reservoir, where we suppose you are standing on a ground. This is ground level and this is the tower like structure where there is a water tank from which water is supplied to required area under the influence of gravity. So elevated tanks which rely on gravity for water supply. It ensures water flowing during power outages. It is useful in firefighting, domestic use, industrial use. It is refilled at night, usually at night, because there is no disturbance, and it supports peak demand during the day. Some towers store non-potable water for industrial use. Another's are dams, reservoirs, ponds and lakes, as we have seen in earlier. So what is a dam? Dam, suppose a river is flowing like this, and it is an artificial structure, it is an obstruction. Suppose the flow of river is obstructed by construction of an obstruction which we call dam, then a pool of water is created on the upstream side of the river, which is usually known as reservoir. So dams, reservoirs, ponds and lakes. Reservoirs are man-made structures via dam construction, and water is usually used for irrigation, hydroelectric power, domestic or industrial supply, flood control. So there are two types of reservoir, impounding reservoir and pump storage reservoir. So impounding reservoirs are built across river valleys, and pump storage are usually filled by nearby rivers. Ponds, the surface area is less than 2 hectares. It holds water for more than 4 months and formed naturally or man-made. It is important in village or rural water infrastructure. So pond is an integral part of village life. Now water conveyance. So there are two key stages of water conveyance: from source to treatment plant and from treatment plant to distribution system. So these are two stages for water supply. One is primary, is from source to treatment plant, where if source is at higher than the plant, then water flows under the influence of gravity. with the use of open channels, aqueducts or pipelines. If the source of water is lower than the plant, then we have to make water flow under pressure. Example, closed pipes which are flowing under pressure with the help of motors or pumps. From treatment plant to distribution system, we have two options, either with the help of pump to the overhead tank, and then from that overhead tank we have to supply water under the influence of gravity, or by direct pumping water into the water main lines. So there are basically two systems from this we can find out. That is free flow system, which acts under the influence of gravity, and another is pressurized flow system, which where water is forced through pipes under the influence of pressure. So here the choice depends upon the elevation, distance and the system designs. The geographical location plays a very important role in the choice of the system. So again, free flow system is under the influence of gravity, and pressurized system where water is forced through pipes under pressure. Now water conveyance structures. So we know that there are various structures like canals, flumes, grade aqueducts and tunnels, where these all are the structures which are used for conveyance of water. Like Sardar Sarovar Dam is situated in Kevadia, but water is transported in various other parts of the state with the help of canal network. So what are canals? Canals are the open channels which is rarely used due to evaporation, percolation and theft. Canals are the open channels, but sometimes they are rarely used in case where there is high evaporation or there are high percolation, but percolation can be addressed if canals are lined or if there is probability of theft of the water. What are flumes? Flumes are elevated open channels, concrete or metal is used over valleys or depressions. Grade aqueducts, they are covered waterways and carry water distribution from the origin to the desired location. And tunnels. Tunnels usually are grade tunnels, means there is a one shape of tunnel is horseshoe tunnel, free flowing tunnel, and pressurized tunnels where it is a natural pipe. It acts as a natural pipe where water flows under the influence of the pressure in the tunnel with the help of either with the help of pump or under the influence of gravity. So material used in this conveyance structures are concrete, brick, steel or metal. Lining is essential to prevent leakages or seepage losses and to improve its durability. What is lining? Lining is a protective layer. It is like a plaster. It is a protective layer which prevents water from seeping through sides as well as through bottom. Now use of pipe in water conveyance structure. Before studying use of pipe, we see here a sketch. This is a metal pipe. These are iron pipes. This is steel pipes. This is asbestos coating pipe. This is concrete pipe. And this is GRP, glass fiber pipe. So what is a pipe? A pipe is a circular closed conduit for water flow. It can carry water under the influence of gravity as well as under the influence of pressure. Like gravity, like sewer lines, and under the influence of pressure, like if we start a motor or pump, then water is supplied through the line. So pipes follow ground profile for efficiency and pressure optimization. The design consideration, we have to consider cost, length of the pipe and pressure handling capacity. Sometimes if this pressure handling capacity exceeds, then there is bursting of pipe. Drain valves are provided at low points to remove debris. So if debris are not removed, then there is chance of choking of pipe or the water discharge carrying capacity of the pipe gets reduced. There are air relief valves at high points to release trapped air and to prevent vacuum created in the pipe. There are surge tanks required, stand pipes required to prevent water hammer effect, pipe bursting. So what are the factors which affects pipe selection or the material which is to be selected for piping, like internal pressure and external loads? Internal pressure and external loads, corrosiveness of the water, if the water is hard or soft water, capital and maintenance cost, we have to study cost benefit ratio, availability of the funds, carrying capacity, durability and easy to repair, stress from the alignment or surge. Usually common pipe materials are cast iron pipe, wrought iron pipe, steel pipe, RCC pipes, RCC is reinforced cement concrete pipe, and PSC is concrete pipes, asbestos cement pipe, plastic pipe, copper pipe, lead pipe, and last one is GRP, glass reinforced plastic pipe or polymer pipe. Now we will see what are the technologies for smart water management. So first technology is digital output instruments like meters and sensors. What does meters and sensors do? They collect and transmit real-time data. Where they are used, example, rain gauges, flow meters, water quality sensors, smart meters for consumption, acoustic leakage detection, pressure monitoring, and asset cameras. SCADA system. They are remotely operated and optimized systems and processes which is helpful in pressure management, pump station and treatment plant. These SCADA systems we have seen in detail in previous part 1. Environmental controls and flow regulations. GIS system means geographic information system, which manages and analyzes spatial information. It helps in asset mapping and management, network modeling, environmental data analysis. It is integrated with SCADA for real-time water network monitoring. Another software systems which stores, processes and reports data, model systems for designing and risk management, for smart billing, hydraulic design, hydrological modeling, cloud-based data hosting. Now what is principles of sustainable urban water management? First of all, we have to define sustainability. What is sustainable development? Means sustainability is the resources which we are using and the benefits which we are deriving should be available for future generations for their use and for their benefits. This is simple definition of sustainability. Now what is sustainable development? According to World Commission on Environment and Development, sustainable development is the development that meets the need of the present without compromising the ability of future generations to meet their own needs, like what I said. So sustainable water supply goals are safe, reliable and sufficient water for all, use of minimal non-renewable energy, we have to avoid abstraction beyond natural replenishment capacity. If we extract more water in a state like Gujarat, there is another problem. The problem is sea water intrusion. Once the sea water gets intruded in the groundwater, it is very much difficult to remove that sea water from groundwater. So we have to extract water within specified limits only so that it can be naturally replenished during rainfall season. Sustainable sanitable goals are providing long-term safe sanitation for all, minimizing health risks and environmental impact, and keeping the city waste output within environment's carrying capacity. Means the sanitation should not create additional pollution in the environment. So there are three dimensions of this sustainable urban water management. First is social, second is economical, and third is environmental. Social, it ensures equitable access and improve the quality of life for all the citizens, means social equality. Economic, it should operate and maintain water systems cost effectively so that it is within the reach of every citizen of the society. And environmental, we have to preserve natural water systems, prevent its overuse, pollution and erosion. So policies and benchmarks for sustainable water management. So national initiatives are Jawaharlal Nehru National Urban Renewal Commission, which focuses on basic urban services like housing, water and sanitation. It has shifted focus to service delivery over just infrastructure. It introduced service level benchmarking, which we called as SLB. Means water supply should be there, wastewater should be treated, solid waste should be collected, storm water drainage should be provided. 28 performance indicators are used to monitor and improve urban utilities. Now what are the benchmark? Means 24/7 water supply. Target is continuous availability of the water. 100% of households should get connections, means universal access. Minimum 135 liters per capita per day of water supply should be there, means adequate per capita supply should be there. 100% metering should be done so that we can track where water is used and we can charge accordingly, and 100% of efficiency in billing and collection so that system is maintained properly. If billing and collection is there, then system maintenance becomes easy. Smart City Mission. 2015 Smart City Mission has been launched. It promotes sustainable and inclusive urban growth. It ensures core infrastructure with smart solution. It prioritizes quality of life, clean environment, water and sanitation access. So these two are basic initiatives like JNURM 2005, Jawaharlal Nehru National Urban Renewal Commission, and Smart City Mission 2015, which focuses on sustainable urban water management. Recent trends in smart water management. So recent trends, which is very much what you can say to the point trend, is demand driven distribution. First of all, distribution was done uniformly. Now as per demand we have to distribute. It uses sensors and data to access area specific demand. It ensures equitable supply and minimizes pressure related leakages. Smart water metering and governance. It replaces traditional water meters with smart meters for real time usage tracking. It improves budgeting, governance and citizen awareness. Example, Pune is installing 2,75,000 smart meters. District cooling means sustainable alternative to conventional cooling using intelligent pipe in HVAC systems to adjust flow, speed and temperature. Cooling towers are used in buildings, in large buildings where centralized AC systems are there. And last but not the least is integrated water management. It is a holistic management. Holistic means what you can say, a 360-degree covering all the aspects of a given scenario, given criteria. Means combines water and wastewater systems for holistic management. It encourages each and every stakeholder for coordination. Public private partnerships. It forms the backbone of smart city ecosystem. Integration of available resources also plays a very vital role in their what you can say efficient management. Sustainable sanitation. What are challenges and principles? Sustainable sanitation is not just a technology, but it is an approach which is based on key principles. So what is the principle? The principle is excreta and wastewater are resources. It is not a waste. So we have to change our attitude and we have to look towards that as a resource, not as a waste. We should try to reuse and recycle to close the loop. The main objective is to ensure health, hygiene and environmental protection by breaking the disease cycle. It is recognized today as a driver for sustainable and economic development. So the attitude changes, the end result changes. What are sanitation challenges? First and the foremost thing is rapid urbanization. Clear policies are required in urbanizing areas like Nagar Panchayats or municipal corporations or corporations. Inadequate maintenance of water infrastructure. Current water infrastructure are somewhat inadequate maintained. So we have to maintain it properly rather than building new. Poor fecal water management. Waste management. Sorry. The waste management, especially the excreta sort, is very poor. So we have to, as we discussed earlier, we have to look it as a resource, not as a burden. Rising groundwater contamination due to various reasons. Over reliance on centralized wastewater systems. Need to upgrade STPs and treatment facilities. Lack of capacity buildings for officials. Weak accountability in urban local bodies. Lack of climate resilient infrastructure. Exclusion of urban poor in planning and decision making, very important point, and inadequate focus on gender sensitive sanitation planning. Like in last decades, very high amount of work is done in the form of construction of toilets in tier 2, tier 3 and villages, where gender based equality reflects that sanitation facilities should be available for all equally and in a closed environment. Open defecation is not at all promoted. Recommendations for urban sanitation. So first is regulatory recommendations, another is institutional recommendation, and third one is management recommendations. So first we will see what is regulations. So we have to develop a facial sludge and septage management strategies in all local urban bodies. We have to regular environment and health monitoring facilities. We have to promote low water and low pollution sanitation options like EcoScan in peri-urban areas. Policies should focus on reuse of treated waste, reduced energy used in operation and maintenance, support climate resilient, eco-friendly and circular economy solutions. Circular economies means we have to close the loop. The cycle should be continuous. It should not be a linear. It should close the loop, so the process is self driven after some time. Institutional recommendation means on site sanitation and support small scale providers, align wash ecosystem with local stakeholders for service sustainability, ensure operation and maintenance of PTs and cities through innovative business models, promote source separation of liquid or solid waste, means the waste should be separated at source itself. Now till now all the waste is collected, then at some common point segregation is done. Now there is change in the attitude also, change in the working parameter also, that from source itself different types of waste is segregated, so our efforts get reduced and our efforts get more aligned. Local and decentralized treatment systems and reuse of waste treated water, modernize sewage treatment via decentralized technologies. And third is management recommendations, means we have to use spatial data to monitor household level latrine use, especially in slums, and we have to conduct as advanced training and capacity building for urban local body staff and stakeholders, so that the system which is developed is utilized in effective way. Innovative sanitation solutions for smart cities. First is low water flush toilets. Before, traditional flush usually uses 13 liter to 15 liters of water in one single flush, means 90 liters per day. If there are 5 members using toilet one time in a day, means 90 liters of water is used. Now new design focuses on 5 liters of flush using spring based siphon system. It saves water, saves electricity by reduced pumping and recycling load. Another is conveyor belt toilet. Nowadays conveyor belts are used which carry excreta and they dump, so no flush water is required. Faces move towards tank via conveyor belt and urine to front tank. It enables biofertilizer use with microbial seeding. Solar powered self cleaning e-toilets, where they are made up of stainless steel, they are application enabled, solar powered, auto cleaned, sensor based. Use is only 1.5 liters of water for single flush versus 8 to 10 liters of flush traditional. Features are automatic lights, exhaust fan, biodegradation of waste treatment. And now the latest is IoT based, Internet of Things based toilet sanitation monitoring, ideal for large facilities like hospitals, station, campuses. Uses odor sensors and WLAN modules, sends real-time alerts to monitoring systems when sanitation levels drops. It enables proactive cleaning and better resource use. So these are 4 innovative technologies. First is low water flush toilets, conveyor belt toilet, solar powered e-cleaning toilet, and IoT based toilet sanitation monitoring. IoT is Internet of Things. Now sewage system in Indian cities, what are the status and challenges? So waste generation, so total sewage in class 1 and class 2 cities is 38,524 MLD. Treatment capacity available is 11,787 MLD, which is almost equal to 30%. Metropolitan cities with cities having more than 1 million of population, only 5 cities like Hyderabad, Chennai treat 100%. Delhi has largest capacity, meets 60% of its needs. Mumbai has second largest, meet 80% of its needs. Most other cities treat only 50% of generated waste. So here is the real time alarming situation that we have to improve our capacity. Now why wastewater treatment matters? It contains toxic elements like cadmium, zinc, mercury, asbestos, etc. Direct disposal harms agriculture and aquatic life. It affects human health through contaminated water use, impacts farm productivity via polluted irrigation sources. So to address all these problems, we have to improve our system, and these are challenges. First is on-site challenge. High cost of sewer network expansion, unplanned urbanization and land conflicts delay STP projects, sewage treatment projects. sewage treatment plant projects, power cuts, skill shortage, and urban local body budget constraints. Many sewage treatment plants underperform due to poor connectivity. Off-site challenges are cost pressures and climate variations. Opportunities for foreign tech in sustainable treatment. Barriers are local compliance issues and unfamiliar procedures. So these are some of the barriers and some are opportunities for off-site challenges. So by addressing all this, we will be able to improve whole system. Sewer networks, present Indian scenario, basically the goal is collection, treatment and safe disposal of sewage. Collection, treatment and safe disposal of sewage. So there are two main systems. One is separate system, another is combined system. In separate system, as we can see, there are two different systems for storm water and for wastewater. Storm water is rainwater. And sewage is handled separately. Whereas in combined system, a single drain is used where storm plus waste or sewage runs in a single pipe. It is less efficient and more costly. India now designs most sewer as separate systems. Current scenario in India is 80% of population lacks proper sewer systems. Open defecation, 55% of rural household goes for open defecation. This amount has been now reduced. 12.6 of urban household goes for open defecation and 18.9% in urban slums. This all data now has been reduced because of efforts of the government as well as awareness among the stakeholders. Amrut and smart water management. What is Amrut? The full form of Amrut is Atal Mission for Rejuvenation and Urban Transformation. Atal Mission for Rejuvenation and Urban Transportation. Target is 500 cities. Objective is to improve urban sewerage infrastructure. The goals are developed a decentralized underground sewerage network, including upgrades to existing sewage treatment plants, rehabilitate aging sewer lines and treatment plants. Means the sewer lines which are very old and the treatment plants which are very old, we have to rejuvenate it, we have to rehabilitate it, we have to capacity build in that. Enable reuse and recycling of treated water for beneficial use. Smart wastewater management means leveraging technology to enhance sanitation services and ensure pollution free clean water. Key benefits are remote monitoring. We can monitor from remote, and problem detection can be done using IoT sensors, Internet of Things sensors. We have to prioritize maintenance. Small maintenance, if not addressed, it turns into a big problem. So we have to address the maintenance at that particular small level only. We have to not, so that the problem does not quantify. Through real-time alerts, empower citizens with data usage for better decision making and ensure compliance with water quality and conservation standards. So these are some of the key benefits of smart wastewater management. And I already gave an idea about Amrut, Atal Mission for Rejuvenation and Urban Transformation. IoT based smart water management system. Internet of Base Things smart water management system. So detecting chemical pollutants and preventing sewerage overflows. These IoT sensors are used to monitor and manage wastewater in real time, helping smart cities to meet growing freshwater demands by detecting chemical pollutants and preventing sewage overflows, enabling efficient communication between systems and administrators, reducing water wastage through quick response of anomalies. Means quick response, small is the problem, quick response, the problem does not quantify. System architecture consists of sensors. Various sensors to measure pH, salinity, gas level, water level are connected to PIC controller. IoT based detection determines wastewater status. It is normal or abnormal. Data is uploaded to cloud storage. It is accessible by multiple users via web or mobile applications. So again, common collection data center or centralizing of data collection so that various stakeholders can make use of it. Advantages of smart wastewater systems: real-time monitoring, quick response to issues as discussed, improved operational efficiency. Because of monitoring and quick response, the operational efficiency increases because centralized data collection and remote access is reduced manual inspections and maintain delays. Enhance customer satisfaction. Integration with customer information system helps you utilize manage supply versus consumption and improve the communication. Accurate demand forecasting means advanced metering, demand management systems allows optimized production and energy usage. How much water will be required in particular area in upcoming 2 years, or how much waste will be generated, that depends upon upcoming projects, current number of citizens residing in that area, and then we can accurately forecast the demand, standard of living of the people, cost saving and resource optimization. It helps to minimize water wastage and energy consumption. It reduces operational cost while ensuring the sustainability. So overall nutshell is sustainable development. So this is for now. I hope you must have enjoyed this section and this session will be helpful to you. Have a good day. Thank you.